These are the answers to the Unit 1 Topic 3 Formative Review Packet, which will prepare you for the upcoming test. In Part 1, we are asked to solve each of the equations for x. Remember that an exponential equation is an equation where your variable is an exponent. In order to solve exponential equations, our goal is to get both sides of the equation to be a power of the same base. So for instance, in this first question, question 1, we have 5 to the power of x and 1 over 125. Our goal is always to make numbers smaller. Now I understand that this is a really small number, but I'm actually just talking about focusing on the 125, or the 49 and the 7, or the 5 and the 125, 4 and the 8. I want to make them smaller, never larger. I can't change 5 into a power of 125, but I could change 125 to be a power of 5. So 5 to the power of x, there's not much we can do about that. But 1 over 125. Before I worry about changing my fraction into a power with negative exponents, I just want to change the 125 into the power of 5. So I'm going to have 1 over 5 to the power of 3, because 5 to the third is 125. Next, I can make this 1 over 5 to the power of 3 to be a power of 5 using negative exponents. Because negative exponents, you take the reciprocal and make the exponent positive, so it works in the opposite direction as well. So we're going to have 5 to the power of x equals 5 to the power of negative 3. Now that my bases are the same, I can use a property of exponents that says when the bases are the same, then the exponents must be equal, and I can set up a new equation where I set the exponents equal to each other. So I'm going to have x equals negative 3, and that's going to be my final answer. Next, we have question number 2. 1/7 to the power of x minus 2 equals 1 over 49 to the power of 2x. Whenever you have exponents that are expressions, I would put parentheses around it, just so you don't forget to distribute later. So 1/7 and 1/49 can both be written in terms of bases of 7. This is going to be 1 over 7 to the first to the power of x minus 2. And 1 over 49 is 1 over 7 to the power of 2 to the power of 2x. Well, 1 over 7 to the first is just 7 to the negative first to the power of x minus 2. And 1 over 7 squared is 7 to the negative second power to the 2x power. Because I've got an expression here, I need to distribute this negative 1 to both terms. So I'm going to have 7 to the negative x power plus 2, because that is negative 1 times x, and negative 1 times negative 2. And that's going to be equal to 7 to the power of negative 4x. Because remember, power of a power says that we multiply the exponents. Now that they have the same base, I can set up a new equation where my exponents are equal to each other. And then I can solve for x. I'm going to add x to both sides to get 2 equals negative 3x. And then I'm going to divide both sides by negative 3 to get x equals negative 2/3. For question number 3, we have 100 to the power of x plus 3 equals 1 over 10,000 to the power of x plus 2. As I said, whenever you have expressions as your exponents, put parentheses around it. Both of these can be written as base 10s. 100 is 10 to the second power to the exponent of x plus 3. And 10,000 is going to be 1 over 10 to the 4th. When you've got powers of 10, you just need to count the zeros to tell you what the exponent is. And this is going to be to the exponent of x plus 2. Next, I'm going to distribute the 2 to the x and the 3 of x plus 3, and I'm going to get 10 to the power of 2x plus 6. And 1 over 10 to the 4th is actually going to be 10 to the negative 4th to the power of x plus 2. So we have 10 to the power of 2x plus 6 equals 10 to the power of negative 4x minus 8. 2x plus 6 equals negative 4x minus 8 because the bases of the equation are the same, so we can set a new equation up where the exponents are equal to each other. I'm going to add 4x to both sides to give me 6x plus 6 equals negative 8. Then I'm going to subtract 6 from both sides to get 6x equals negative 14. And once I have 6x equals negative 14, I'm just going to divide both sides by 6 to get x equals, now both of these are even numbers, so I can divide by 2 and get negative 7/3. Always simplify your fraction. For question number 4, we have 4 to the power of x minus 5 equals 8 to the power of 2x plus 2. A common misconception is to try to change 8 into a base of 4, but you can't because 4 squared is 16, which is past 8. However, both of these can be written as bases of 2. So 4 becomes 2 squared to the power of x minus 5. And 8 becomes, and don't forget to put your parentheses around your expression if it's in your exponent, 8 becomes 2 to the 3rd to the power of 2x plus 2. So I'm going to distribute out, and I'm going to have 2 to the power of 2x minus 10, because that's what 2 times x and 2 times negative 5 is. And I'm going to distribute my 3 to have 2 to the power of 6x plus 6. Because I have the same base, I can write a new equation where my exponents equal each other. And I'm going to have 2x minus 10 equals 6x plus 6. I'm going to subtract 6x on both sides to get negative 4x minus 10 equals 6. I'm going to add 10 on both sides to get negative 4x equals 16. And then I'm going to divide by negative 4 to get x equals negative 4. For problem number 5, I'm going to have 5 to the power of x minus 6 equals 125. Well, I can see that 125 can be written as a base of 5. So I'm going to keep 5 to the power of x minus 6 equals 5 to the power of 3. Since the bases are the same, I can set my exponents equal to each other. So x minus 6 equals 3. I can add 6 to both sides. So we have x equals 9. And finally on this page, I have 1/2 to the power of 4x plus 1 equals 8 to the power of 2x plus 1. Well, 1/2 can be written as 2 to the negative 1st to the power of 4x plus 1. 8 can be written as 2 to the power of 3 to the power of 2x plus 1. So I'm going to distribute out, and I'm going to have 2 to the power of negative 4x minus 1 equals 2 to the power of 6x plus 3. Since my bases are the same, I can set the exponents equal to each other. I'm going to subtract 6x to get negative 10x minus 1 equals 3. I'm going to add 1 to both sides to get negative 10x equals 4. And then with that, I'm going to divide both sides by negative 10. Since they're both even numbers, I know that I can divide both the numerator and denominator by 2 to simplify my fraction. So I'm going to have negative 2/5. X equals negative 2/5. So questions 7 and 8, we're still solving the equations for x. So we have 256 to the x plus 2 equals 4 to the power of 2 minus 2x. Since you can't use a calculator on the test, use what the equation gives you to give hints. For instance, I can see that this is a base of 4. I've never really seen this 256 before. It seems to be a really large number, but I can make an assumption that it's going to be a base of 4. Well, I know 4 times 4 is 16, and 16 times 4 is 64. So if I need to, keep going. 64 times 4, 4 times 4 is 16, plus 1. 6 times 4 is 24, plus 1 is 25, 256. So if this was 4 times 4 times 4, then this will be, with another 4, this will be 4 to the 4th to the power of x plus 2 equals 4 to the power of 2 minus 2x. Since the 4, this exponent of 4, has to be distributed to x plus 2, we're going to have 4 to the power of 4x plus 8 equals 4 to the power of 2 minus 2x. 4x plus 8 equals 2 minus 2x. I'm going to add 2x to both sides. 4x plus 2x is 6x, plus 8 equals 2. I'm going to subtract 8 on both sides, so 6x equals negative 6. And then to solve for x, I'm going to divide both sides by 6, and x is going to equal negative 1. For number 8, I've got 8 and 16. Now my gut first would be like, oh, 16, I can make that into a base of 8 because 8 times 2 is 16. But remember, we're dealing with exponents, and that doesn't really work. So then I could think 16, 4 squared. But remember, I can't make 8 into a base of 4. But I can make them both into bases of 2. So it's going to be 2 to the 3rd to the 2x plus 4 power. And 16 will be 2 to the 4th to the x plus 1 power. I'm going to multiply my exponents together, distribute it. So I'm going to have 2 to the power of 6x plus 12. And I'm going to have 2 to the power of 4 times, distribute it to the x plus 1. So 2 to the power of 4x plus 4. Since my bases are the same, I can set my exponents equal to each other. So 6x plus 12 equals 4x plus 4. I'm going to take away 4x. From both sides. 6x minus 4x is 2x plus 12 equals 4. I'm going to take away 12 now. And I'm going to have 2x equals negative 8. Well, if 2x equals negative 8, and I divide both sides by 2, then x must equal negative 4. All right, now we have a word problem. At 5 a.m., Miss Sexton leaves a serving of yogurt on a table. The number of bacteria in Miss Sexton's yogurt at that time is 1. The number of bacteria in her yogurt increases by a factor of 3 every minute. That means to multiply by 3 every minute. 12 minutes later, at 5:12, Mr. Simkoviak accidentally heats a serving of yogurt in the microwave. Talk about gross. The number of bacteria in Mr. Simkoviak's yogurt at that time is 1, but due to the increased temperature, the bacterium increases by a factor of 27 every minute. At what time will the number of bacteria in each yogurt be the same? So the first thing we have to do is set up a variable, and we write a let statement for that. So let's say let t equal number of minutes after our starting time, which is 5 a.m. So number of minutes after 5 a.m. This way at 5, t is 0, at 5:01, t is 1, at 5:02, t is 2, and so on. Next, let's look at Miss Sexton's yogurt. So she starts with 1 bacteria, and it increases by a factor of 3. So we know since we're multiplying by 3, that's going to be our base. And since Miss Sexton's yogurt starts at 5 a.m., this is going to be 3 to the power of t. So at 5 a.m., t is 0, 3 to the 0th equals 1. At 5:01, there's 3. So 3 to the first is 3. At 5:02, there's 3 to the second, which is 9. Mr. Simkoviak, on the other hand, his bacteria increases by a factor of 27 every minute. So we know that our base is going to be 27. But his doesn't start until 12 minutes later. So we know at 5:12, he's got to have 1 bacteria, which means this is going to have to be 27th to the 0th power. So how can I get t to be 0? Well, we know that at this time t is going to be 12, so I have to subtract 12 to get me to 0. So this is going to be 27 to the t minus 12 power. Because at 5:12, when t is 12, 12 minus 12 is 0, 5 to the 0th is 1, and that is his starting amount of bacteria. We want to know at what time will the number of bacteria in the yogurt be the same. So we want to know when is 3 to the power of t going to equal 27 to the power of t minus 12. So 3 to the power of t is going to equal 27, which can be written as 3 to the third to the power of t minus 12. I need to distribute. So 3 to the power of t equals 3 to the power of 3t minus 36, because 3 times negative 12 is negative 36. This means that my bases are the same, so I can set my exponents equal to each other, and we have t equals 3t minus 36. So I'm going to rewrite that equation over here, and I need to solve, not 3t, but I meant 36. And I need to solve for t. So I'm going to subtract 3t on both sides, and I'm going to have negative 2t equals negative 36. To solve for t, I need to get rid of the negative 2, so I'm going to divide, and I'm going to have t equals 18. Finally, we need a therefore statement. So at what time? Well, if t equals 18, this means that it's at 5:18 a.m. So at 5:18 a.m., the number of bacteria will be the same. Part 3. Students at TMS were conducting a science experiment on fruit flies. At 8 a.m., Layla decided to leave a fresh apple in a contained space and noticed that the fruit flies were increasing by a factor of 4. 30 minutes later, Mitchell decided to leave a week-old apple in a contained space and noticed that the fruit flies were increasing by a factor of 16. At what time will the number of fruit flies in Layla's and Mitchell's experiment be the same? So the first thing is let's set up our let statement. Let's let t equal number of minutes after our starting time, which is 8 a.m. So number of minutes after 8 a.m. So we have Layla first. And Layla has an apple where the fruit flies are increasing by a factor of 4. And since hers starts at 8 a.m., she's going to be 4 to the power of t. However, Mitchell has fruit flies that are increasing by a factor of 16. So we know our base is going to be 16. But his started 30 minutes later. So we know that if t equals 8 a.m., and we're trying to get 8:30, this would be t equals 30. Now we want Mitchell to be 0 at that time. So how can I go from 30 to 0? By taking t and subtracting 30. So 16 to the t minus 30 power is going to be Mitchell. Next thing is I want to know at what time the number of fruit flies will be the same. So I want to know when will 4 to the power of t equals 16 to the power of t minus 30. I can see that 16 can be a base of 4. So I'm going to have 4 to the power of t equals 4 squared to the power of t minus 30. But on a side note, you could have also had 2 squared to the power of t equals 2 to the 4th to the power of t minus 30. And as I'm just reminded, put parentheses around your exponent when they're expressions. So either answer is going to give you the same answer in the end. So we have 4 to the power of t equals 4 to the power of, and I'm going to distribute my 2. So I'm going to have 2t minus 60. Since my bases are the same, I can set my exponents equal to each other. So t equals 2t minus 60. I'm going to subtract 2t. It's going to get us negative t equals negative 60. And to get t by itself, I'm going to divide by negative 1 to get t equals 60. Again, I can do the same thing over here. I could have had 2 to the power of 2t equals 2 to the power of 4t minus 120, and 2t would equal 4t minus 120. Subtract 4t. Negative 2t equals negative 120. Divide by negative 2, and t would equal 60. So either base that you choose to use, you're going to get the same answer. So in the end, we're going to write our statement, our therefore. So t equals 60 is 60 minutes after 8 a.m., which is 1 hour. So at 9 a.m., the number of fruit flies will be the same in each experiment. Great. Moving on to the last part, this is dealing with monomials. Remember, a monomial can be a number, it can be a variable, or it can be a product, keyword product, which is multiplication, or division, because division is multiplication of a reciprocal. So, or a product of numbers and variables. So my big hint when it comes to any operations with monomials is to group your like terms. So my like terms here are 4 and 2. Those are my numbers. So using the commutative property, I can reorder this and say 4 times 2 and r to the negative third times r squared. Well, 4 times 2 is 8, and r to the negative third times r squared is going to be r to the negative first. But we also know that r to the negative first is 1 over r to the first. So my simplified answer for this is going to be 8 over r. For number 2, I'm going to do the same thing, and I'm going to group my numbers together, so 4 times 2. And I'm going to have n to the fourth times n to the negative third. Well, 4 times 2 is 8, and n to the fourth times n to the negative third is 4. I'm going to keep the base and subtract the exponent, so 4 minus 3 is 1. So I could leave this as my answer, or just 8n. For number 3, I'm going to have my numbers together, so 2 times 4, and my variables, k to the fourth times k. Well, 2 times 4 is 8, and k to the fourth times k is k to the fifth. So I'm going to have 8k to the fifth. Finally, for number 4, I'm going to put my numbers together, so 2 times 2. I'm going to put my x's together, so x to the third times x to the negative first. And I'm going to put my y's together, y to the negative third times y to the third. 2 times 2 is 4, so that's pretty straightforward. X to the third times x to the negative first is going to be x to the second, because 3 minus 1 is 2. And y to the negative third times y to the third is going to be y to the 0th, which also equals 1. So my final answer is going to be 4x squared. For number 5, I have x squared to the 0th power. We know that 2 times 0 is 0, so we get x to the 0th, which equals 1. It always equals 1. Anything to the 0th power is 1 except for 0, which is undefined. For number 6, we have, and what I'm going to do is distribute this outside exponent to each different part of the inside term. So this is going to be 2 to the negative fourth, and we're going to have x squared to the negative fourth. Well, 2 to the negative fourth is 1 over 2 to the fourth. And x squared to the negative fourth is x to the negative eighth. So this is going to be 1 over, now 2 to the fourth is 16. And x to the negative eighth is 1 over x to the eighth. So simplify this together, we have 1 over 16 x to the eighth. Another way to do this is to deal with the negative exponent first and have 1 over 2x squared to the 4th power. Still, we'll have to take that exponent of 4 and distribute it to the 2 and to the x squared, but at least this way it gets rid of negatives early on. All right, number 7, 4 times r to the 0th to the 4th power. Well, I know that I'm going to take my 4, this exponent of 4, and distribute it. So I'm going to have 4 to the 4th and r to the 0th to the 4th power. Well, 4 to the 4th is 256. And 0 times 4 is 0, so we're going to have r to the 0th, which is actually equal to 1. So we can finish our answer at 256. With number 8, we now have division. But I'm still going to group my like terms just like I do with multiplication, but with division. Here, we can pretend that there's a number 1 there. So this would be like 3 divided by 1 times m to the negative 4th times m to the 3rd. If you want and you know this, you could say 3 over 1 and then 1 over m to the 4th times m to the 3rd, because you see that this negative exponent should actually be in the denominator and positive, which will give you an answer of 3 over m to the 7th. You could also subtract negative 4 minus 3 and get negative 7, and then arrive at this answer of 3 over m to the 7th. Because remember, we always only have positive exponents in our final answers. For number 9, I'm going to distribute the 2 to both terms. So I'm going to have 4 squared and a to the 3rd squared. Well, 4 squared is 16, and a to the 3rd squared is 3 times 2 is 6, so a to the 6th. For number 10, again, there's a couple different options I have. This time maybe I'll deal with the negative exponent first. This will change this to 4x squared y to the 1st power, 1 over that. So 1 over 4x squared y is going to be 4x squared y to the negative 1st power. This just simplifies to 1 over 4x squared y. With number 11, we have x squared y to the negative 1st to the power of 2. So I'm going to distribute this exponent of 2 to each part. And I'm going to have x squared to the power of 2 and y to the negative 1st to the power of 2. Well, x squared to the power of 2 is x to the 4th, and y to the negative 1st times 2 is y to the negative 2nd. So when I have this, x to the 4th is still staying over 1, because that has nothing to do with negative exponents. But y to the negative 2nd is a negative exponent, so I'm going to have 1 over y to the 2nd to make this positive. And this is going to simplify to x to the 4th over y squared. For number 12, we have m to the 4th divided by 2 times m to the 4th. Remember, if there's no number there, you could say 1. So what I'm going to have is 1 over 2. So that's me grouping my numbers. And now I'm going to group my m's. M to the 4th divided by m to the 4th. So this is going to be 1/2 times m to the 0th, which is 1. So this is going to equal 1/2. For 13, I'm going to group my like terms together. So I'm going to have 2 divided by 3 grouped together, x to the 4th divided by x squared grouped together, y to the negative 4th divided by y to the negative 3rd grouped together, and z to the negative 3rd divided by z to the 4th grouped together. Well, there's nothing I can do with 2/3, so that's going to stay. So 2 divided by 3 times x to the 4th divided by x squared. I'm going to keep the base and subtract the exponents. So I'm going to have x to the 2nd. Y to the negative 4th divided by y to the negative 3rd. I'm going to keep my bases the same, and I'm going to subtract my exponents. Negative 4 minus negative 3 is actually negative 4 plus 3, which is negative 1. And then finally, z to the negative 3rd divided by z to the 4th. I'm going to keep the bases the same, and negative 3 minus 4 is negative 7. So this is going to simplify into 2 over 3 times x squared over 1 times 1 over y times 1 over z to the 7th, which simplifies to 2x squared over 3yz to the 7th. And finally, question 14. For this one, we're going to group all of our numbers together, so 5 times 3. We're going to group our a's together, so a squared times a. Our b's, so b to the 9th times b squared. And finally, c to the 4th times c to the 3rd, our c's. Well, 5 times 3 is 15. A to the 2nd times a is a to the 3rd. B to the 9th times b to the 2nd is b to the 11th. And c to the 4th times c to the 3rd is c to the 7th. And there is my final answer. And this concludes the Unit 1 Topic 3 Formative Review Packet.